Okay, so here we are in question 1 of this paper. The diagram shows the graph of y is equal to mod f of x, where f of x is a cubic polynomial. Find the two possible expressions for f of x in terms of linear factors with integer coefficients. Okay, well, in order to do this, we need to know the factor theorem. So what is the factor theorem? It can be simply stated as this. If x equals alpha is a root of the polynomial of f of x, then it follows then x minus alpha is a factor of f of x. Okay, so that's the key thing. So basically, if 2 is a root, x minus 2 is a factor. If 3 is a root, x minus 3 is a factor. If negative 5 is a root, then x minus 5, so x plus 5 is a factor. Okay, so that's the factor theorem. What is a root? Just so that we're totally clear, it's the same thing as an x-intercept. So if we look at this graph here, we've got 3 roots. We've got x is equal to negative 4, x is equal to positive a half, and x is equal to positive 2, right? So we can write down the 3 roots. X is equal to negative 4, x is equal to positive a half, and x is equal to positive 2. Well, if that's the case, then what are the factors going to be? The factors are going to be x minus 4, so x plus 4, x minus a half, okay, and x minus 2, right? So on the left-hand side here, what I've got is I've got the roots, and on the right-hand side, what I've got is I've got the factors, okay? Now, these are all linear factors, right? But they're not all linear factors with integer coefficients, right? This guy here is a fraction. So how can I change that? Well, I can multiply the whole thing through by 2. So if I multiply the whole thing through by 2, then what I'm going to get is 2x minus 1. And so then I've changed this into a linear factor, but now with integer coefficients, okay? And if you're not sure about that, this thing is still going to give us a root that is equal to a half, because if you just think about it for 1 second, if we set 2x minus 1 equals 0, then if we solve that, we get x is equal to half, right? So the root is still a half, the factor theorem still holds. Okay then, so we know therefore that our polynomial f of x is going to have the following form. It's going to have the factors x plus 4, 2x minus 1, and x minus 2, okay? But it's also going to have some constant k at the beginning, right? Because, you know, we don't know if this is going to be 2x squared or 4x squared or whatever, 5x squared. So we've got to find out what that constant k is. And how can we do it? Well, we can consider the y-intercept here, okay? So we can say that when x is equal to 0, our y value in this case will be equal to 24. Now, we've got to be a little bit careful here, right? Because this is actually the modulus graph. So this could actually be 24, or it could have been the value negative 24, but reflected up. So we need to be aware of that. But for the moment, I'm just going to treat y as equal to 24. So if I substitute in here, I'm going to get that 24 is equal to k. 0 plus 4 is 4. 0 minus 1 is minus 1. And 0 minus 2 is minus 2. So if I multiply that out, I get that 24 is equal to 8k. Okay, and therefore k is equal to 3. Okay, and so if k is equal to 3, I could either have the situation where it's positive 3 or it is negative 3, right? So if I want to write this out now in full, I could say that f of x is equal to the same thing, right? X plus 4, 2x minus 1, x minus 2, but then plus or minus 3. Okay? And that deals with the modulus. All right, then question 2. This is an indices question. Given that 256 to the power of x plus y times by 16 to the power of negative 2x is equal to 8 to the power of negative x plus 3y, show that y is equal to 3x. Okay, this is only 2 marks, so it shouldn't be too difficult. Hopefully what you should notice is that all of these numbers, 2, 5, 6, 16, and 8, are all of base 2. So we want to write each of these guys in terms of base 2. Now, if you're not sure about that, we can just start right 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, and so on and so on and so on. Well, 2 to the power 1 is 2, and then as I keep going up in powers, right, I'm just doubling, right? So double, I get 4, 8, 16, 32, 64. So that'd be 128. So 2 to the power 8, right, is going to be 256, okay? All right, so I've got all the powers I want there. So 256, right, I can rewrite this as 2 to the power of 8 to the power of x plus y times by 2 to the power of 4 to the power of negative 2x is equal to 2 to the power of 3 to the power of negative x plus 3y. And then what rule do I need to apply? Well, I need to use one of the indices rules that if I've got a to the power of, let's call it x to the power of y, then I multiply those two powers, I get a to the power of x times by y, right? So that's what I'm going to do here. So I'm going to take these powers, power of 8, and times it by x plus y. And so if I do that, I get 2 to the power of 8x plus 8y. And again, if I do it with the second one, I get 4 times by negative 2x. That's negative 8x, beg your pardon. Like that. And same thing over here. 3 times by negative x plus 3y is negative 3x plus 9y. Okay, then, second indices rule. If I've got a to the power of x times by a to the power of y, then I add up the powers. I get a to the power of x plus y. And so that's what I'm going to do on the left-hand side. So on the left-hand side, I've got this plus this. So 8x minus 8x will be 0. So I'm going to be left with 2 to the power of 8y is equal to 2 to the power of negative 3x plus 9y. And of course, if that's the case, right, then these two powers must be the same. So I can just straight away write that 8y must be equal to negative 3x plus 9y. And so that means that 3x will be equal to y. Okay, and that's what we're asked to show in the question, right? Show that y is equal to 3x. So we can move on to the next part right now. Hence, find the exact solutions of the following simultaneous equations. Right, this thing here, blah, 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 which we've already simplified. And this one here, x squared plus 3y squared is equal to 56. Well, as we just said, right, this thing simplifies to give y is equal to 3x. So really what we've got to do is we've just got to substitute y is equal to 3x into this equation here. So if I just do that, I'm going to get x squared plus 3 times by 3x all squared is equal to 56, which gives me x squared plus 3 times by 9x squared, because 3x times by 3x is 9x squared. And then 3 times by 9x squared is 27x squared. So I get x squared plus 27x squared is equal to 56. So therefore 28x squared is equal to 56. So x squared is going to be equal to 2. And so therefore x will be equal to plus or minus the square root of 2. Okay? And of course we're solving simultaneous equations, aren't we? So we need to remember what our y value is as well, which is 3x. So if y is equal to 3x, then our y value will also be plus or minus 3 root 2. And we should probably leave that as coordinates as well, just to be totally clear. So we've got root 2, 3 root 2, and minus root 2, and minus 3 root 2. Okay, and what I'm just going to do is just going to very quickly check my answer, see if that is all correct. And yeah, that's absolutely right. And good. See you at the next question. Okay, question 3, a trigonometric graph question. And one that I think is actually a little bit harder than we usually see. Now, as I do with all these questions, what I'm going to do is I'm going to explain the basic idea. So if we've got a graph y equals a times by cos bx plus c, we really need to understand what those values A, B, and C represent. So let me try to do it, and I'll do it in reverse order, as I always do. Firstly, what does C represent? It represents the shift in the y direction, which tells us where the center line of the sine or cosine graph is going to be. So essentially, it kind of tells you where that line is. Okay. Now, I think a lot of students are going to look at this and go, "Ooh, it must be 3, right?" Because it kind of looks like halfway along, but that's not going to be right because the whole graph goes further down. So you want to be very cautious about guessing, but you need to be aware that that is what C represents, right? C represents that kind of central line. Okay, what about B? Now, the classic error with B is that students seem to think that it is the period of the graph. It is not the period, right? It is the number of waves in 360 degrees, or if you're using radians, in 2 pi radians. Now, that is related to the period, but it is not the same thing, right? So, for example, if B is 2, what that means is that there are 2 waves in 360. If B is 3, it means there are 3 waves in 360. So how could we use that to calculate the period? Well, what is the period? The period is just how long one wave is. And so therefore, it will be given by 360 degrees divided by the value of B. Let's just try to think that one through. If B is 2, it means there are 2 waves in 360 degrees. So how big is one wave going to be? Well, it's going to be 360 divided by 2. It's going to be 180, right? Because if there are 2 of them in 360, it means that one of them has got to be half that. If B is 3, right, it means that there are 3 waves in 360. So if there are 3 waves in 360, how big is one wave? Well, it's going to be 360 divided by 3, which is 120. Okay, so if you've got it in your head that B is the period, you need to get it out of your head right now, right? That is the biggest error. B is not the period. It is basically what we call the circular frequency, the number of waves in 360, and it is related to the period, okay? But they're not the same. Lastly, A. What is A? A is the amplitude. It is the distance from the center line to the peak or down to the trough, to the bottom. Now, in this question, we are told that we have a period of 960. That's like the definite piece of information that we're given there. So we are told that T is equal to 960. So therefore, what's B going to be? B is going to equal to 360 degrees over T, right? And T is 960. So that's going to be 360 degrees divided by 960. Okay, let's assume we don't have a calculator. We can cancel off that and that, can't we? And then we can divide top and bottom, I think, by 3 fairly easily. So 36 divided by 3 is 12. 96 divided by 3 will be 32. And then those look like they divide by 4. So that's going to give us 3/8. Okay, so B is equal to 3/8. And that means we can automatically rewrite our equation as y is equal to A times by cos 3/8 of x plus c. Okay then, so what's the other information we've got? Well, we've got these things here, right? We've got the x-intercept and we've got a y-intercept. So basically we know that when x is 320, y is 0, and when x is 0, y is 6. So we can substitute that into here and get some equations. So let's try that. So when x is equal to 320 degrees, y is equal to 0. That's the x-intercept. So therefore 0 is equal to A times by cos. Okay, well, what's 3/8 of 320? Well, an eighth of 320 is going to be 40 degrees, right? And then 40 degrees times by 3 is going to be 120. So we're going to have cos of 120 degrees plus c. And cos of 120 degrees is going to be -1/2, I think, if you stick that into a calculator. So you're going to get 0 is equal to -1/2 A plus C, or if we prefer, we could say that 0 is equal to -A plus 2C. Okay, just multiply through by 2. Okay, the next one, we can do the y-intercept, right? So when x is equal to 0, y is equal to 6. So let's substitute in there. So we got y is equal to 6, a cos 0 plus c. Well, what is cos 0? Cos 0 is equal to -1, isn't it? So we got 6, sorry, cos 0 is equal to +1, do beg your pardon. So 6 is equal to a plus c. So hang on, we've got two equations and we've got two unknowns, right? So here are two equations, right? Equation 1, equation 2. So what do we do if we've got two equations and two unknowns? Well, it's simultaneous equations. And I'll just do this by elimination. I'll add up equation 1 and 2. So 0 plus 6 is 6. Negative a plus a is 0. 2c plus c is 3c. And therefore, what does that mean? That means that c is equal to 2. Okay, and if c is equal to 2, I can substitute it into equation 2. So a plus 2 is equal to 6, which means that a is equal to 4. Okay, so I get the answer, a is 4, b is 3/8, and c is 2. So that means that the graph is y is equal to 4 cos 3/8 x plus 2. And again, what I'm going to do, I'm just going to check that that is the right answer. Let's go down. Yeah, and that is the right answer. Okay. Okay, question 4. This is basically an integration question. So given that this integral is equal to ln 16, find the exact value of the constant a. So let's just get on and integrate the function. We're going to integrate between 0 and 2a plus 1, 8 over 4x plus 3 dx. So what are we going to get? We're going to get 8, so we kind of just pull the 8 out as a constant. How do I integrate 1 upon 4x plus 3? Well, that becomes a natural log. So I get the natural log of 4x plus 3. And then I need to take the coefficient of the x, which in this case is 4, and divide through by 4. All right, so that's the rule for integrating a function of this form, which you'll just need to effectively memorize how to do that. Okay, so then I'm going to do that between the boundaries of 2a plus 1 and 0. And of course, 8 divided by 4, right, this thing is equal to 2. So I think what I'll do is I'll just straight away remove that and just write that as 2. Okay, so now let's substitute in. So I've got 2 ln, substitute in 2a plus 1, so that's going to be 8a plus 4 plus 3. And now substitute in 0, right? So I get 2 ln, 4 times by 0 is 0, plus 3 is 3. So I can then factorize out the 2. So I get 2 bracket ln of 8a plus 7 minus ln 3. And I can use a log rule, because what I've got here is I've got ln a minus ln b, and ln a minus ln b is ln a over b. So this is going to become 2 times by the natural log of 8a plus 7 over 3. Okay, if you're not sure about that, let me just state the rule for you over here. The rule is as follows. If I've got log a plus log b, that's equal to log of a times b. And if I've got log a minus log b, that's equal to log of a divided by b. And then the third rule, because we're going to have to use it in just a second, is if I've got p times by log a, then that is the same thing as log of a to the power of p. So if I just move across here, right, I'm now going to use the third rule. I'm going to take that coefficient of 2, I'm going to bring it up as a power. So now what I've got is I've got ln of 8a plus 7 upon 3 all squared. And we're told in the question, isn't it, that this is equal to ln 16, right? So we know that this is equal to ln 16. Well, if that's the case, right, then this thing here must be equal to that thing there. So we can just skip straight ahead and say, okay, that means that 8a plus 7 upon 3 all squared is equal to 16. And if we square root both sides, we'll get 8a plus 7 over 3 is equal to plus or minus 4. Okay, and I'll multiply through by 3, so 8a plus 7 is equal to plus or minus 12. And if we've got positive 12, right, then that's going to be 8a is equal to positive 12 minus 7, which is 5. So a is equal to 5/8. Okay, and then if we've got negative 12, then we've got 8a is equal to negative 12 minus 7, which is negative 19. And so a would be equal to negative 19 upon 8. Now, you need to use your, just think a little bit, right? Use your brain a little bit. If we go back and we read the question, it does say find the exact value, right? Not values, value. There's only one of them. So we've got two values here, right? So one of these guys can't be right, needs to be excluded. Which one has it got to be? Well, if we look at the question, we're asked to integrate from a lower bound of 0 up to an upper bound of 2a plus 1, right? And that means that if we take this negative guy, right, this can't be right, because it means that this upper bound here is going to be negative, right? So this lower bound, right, is supposed to be lower than our upper bound, right? So if this guy is actually lower, then that means that something's gone wrong. So we are limited to the fact that the a value must be the positive one in this case, right? So a is equal to 5/8. So this is an excluded, right? So we need to write that, something like excluded. The only answer is going to be this guy here. Now, guys, they kind of like doing things like that, right? They like to trip you up when you do the exam, because you kind of do all the working, do all the algebra, work really hard, and then you get to the end, you've got two answers, and you kind of put them both down, and you lose a mark because temporarily you've lost sight of the question. So when you read the question, you want to be very sensitive to things where it says, like, just find the value, right? Right. If you see that there, you need to kind of pause and write down there's only one value. Because I think otherwise, when you get to the end of the question, what's going to happen is you're human, you will just forget. Okay, all right. Okay, then question 5, a binomial expansion style of question. So in the expansion of this, where k is a constant, the coefficient of x cubed is this thing here. Find the value of k. Okay, now guys, basically you want to try to understand what's happening when you're doing a binomial expansion. When you're doing a binomial expansion, right, every single term looks like the following. We're going to have the first term, in this case 1, to some unknown power. And we're going to have the second term, which in this case is kx, to another power. And then preceding that, there's going to be a coefficient which will be given by 15c something, where this something here is either going to be that power or that power. It doesn't matter which one. Now then, in this case, we want the coefficient of x cubed, right? So we want this x term here to be 3, right? Because if I make that power 3, then we're going to get an x cubed term. Okay, what else do we know? We know that the two powers here and here have got to add up to be 15, right? In other words, we're going to have either 0 and 15, 1 and 14, 2 and 13, 3 and 12, and so on. So if this power is 3, then that guy there's got to be 12. And therefore, the number that goes in the blank here is either 3 or 12. It really doesn't matter. Just choose 3. Okay, so then if we were to expand this, we would get 15c3, which is the same thing, right, as 15 factorial over 3 factorial, 15 minus 3, which is 12 factorial. 1 to the power of 12, beg your pardon, is just 1. And kx cubed is equal to k cubed x cubed. So then this whole thing here is going to be the coefficient of x cubed. And we are told that that thing is equal to this thing, negative 29120. So if I was to write that down, 15 factorial over 3 factorial, 12 factorial, k cubed is equal to negative, was it 29120? Okay. Then we can do that. Now, of course, if you had a calculator, right? So let's assume, you're doing in the past where you were allowed calculators, or you're doing the non-calculator version of the paper in the future. Obviously, what you would do, you were doing the calculator paper in the future. You would just key this into into your calculator, right? 15C3, and you'll just get the number. In this case, I just want to kind of help you a little bit by giving you some tricks if you don't have your calculator or your calculator doesn't work or whatever. 15 factorial over 12 factorial is going to be 15 times by 14 times by 13, right? Because the 12 times 11 times 10 times 9 times 8 is going to be cancelled off by this. Divided through by 3 factorial, okay, is equal to, times by k cubed, is equal to negative 29120. What's 3 factorial? 3 factorial is 3 times by 2. 3 times 2 times 1 to be precise. So how could I simplify that? I could divide top and bottom by 3. That makes that 5. Top and bottom by 2. That makes that 7. So what would I be left with? I'd be left with 5 times by 7 times by 13 times by k cubed is equal to negative 29120. All right. And if you didn't have your calculator, you know, that would be irritating, right? To have to do divide like that, to do long division, maybe 2 or 3 times. But it is possible. It is doable. Now, what I'm going to do is I'm just going to key it into a calculator just to save time. So if I divide both sides by this thing here, 5 times 7 times 13, then what I'm going to get is I'm going to get negative 64. And therefore, k is going to be equal to negative 4 because I cube root both sides. Okay, I'm just going to double check very fast that that is in fact the right answer. Yeah, k is equal to negative 4. Okay, so that's part A. Well, then let's go to the next part. Let's do part B. We want to find the term independent of y in the expansion of this whole thing here. Well, again, actually, it's the same principle, right? If I've got 8y squared plus minus 1 upon 2y, all to the power of 12, then what is each term of that expansion going to look like? Well, I'm going to have an 8y squared to some power. I'm going to have a negative 1 upon 2y to another power, and I'm going to have 12c something, where this something is either going to be that power or that power. Now, again, I want to have 2 numbers that are going to add up to give 12. But I also want those 2 numbers to be such that these y's are going to cancel off. Now, how could I select that? Well, I mean, let's just think about it, right? If I chose, let's say, 3 and 9, that's not going to work, right? Because that's going to give me a y to the power of 6 and a y to the power of 9, so it's not going to cancel off. Well, with a little bit of careful thinking, right, hopefully what we can see is that if I chose that to be 4 and that to be 8, then this is going to give us a y to the power of 8, and that's going to give us a y to the power of 8, which means that all the y's are going to cancel off, right? So we're happy we've met our condition. And so this thing here can be either 4 or 8. That we'll just call it 4. So then let's try to go through it. We've got 12c4. What's 12c4, right? It's 12 factorial over 4 factorial times by 8 factorial. We've got 8y squared all to the power of 4. So that's going to be 8 to the power of 4 times by y to the power of 8. And then we've got negative 1 upon 2y to the power of 8. Well, what's going to happen there? Well, firstly, the negative is going to become positive because we've got an even power. And so here what we're going to get is we're going to get 1 over 2 to the power of 8, y to the power of 8. Now, those y's are going to cancel off. That's what we like. And I just want to show you that hopefully we can also do this without a calculator, or at least get some way. So this thing here, right? I've got 12 times 11 times 10 times 9 times 8 times 7 times 6, blah, blah, blah. But it's divided by 8 times 7 times 6 times 5. So the terms are going to cancel off, and I'm just going to be left with 12 times by 11 times by 10 times by 9. And on the bottom, I'm going to have 4 times by 3 times by 2 times by 1. Okay, 8. 8 is the same thing as 2 to the power 3, right? So I've got 2 to the power 3 to the power 4. And on the bottom, I'm going to have 2 to the power 8. So now let's try to cancel this off. Well, 4 times 3 is 12, right? So I can cancel off the 12. And I can divide top and bottom by 2. So the 10 becomes a 5. So if I was to simplify this, I've got 11 times by 5 times by 9. This is 2 to the power of 12. And then divided by 2 to the power of 8. So if I've got 2 to the power of 12 and I divide it by 2 to the power of 8, right, then I can subtract the powers. So I've got 11 times 5 times 9 times by 2 to the power of 4, which is 16. Okay, so I'm going to end up with 11 times by 5 times by 9 times by 2 to the power of 4. So I'll go the full way, right? We've got 11 times by 5 times by 9, 2 to the power of 4 is 16. What's 9 times 16? Well, I can think of 10 times 16, which is 160, and minus 16 is 144. Okay, then I'm going to do 5 times by 144. What's a fast way to times by 5? I can divide by 2 and times by 10. So 144 divided by 2 is 72, times by 10 is 720. So I get there 720. And then if I want to times that by 11, how could I do that? Well, I can times it by 10, so 7200, and then add 720 again. And that will give me 7920, which I think should be my answer if I just check the mark scheme again. Yeah, 7920. Okay. Now, guys, you're probably wondering, why have I bothered doing all that? Surely it's just easier just to use a calculator. Well, I'm just aware, right? Obviously, as we move into 2025 and beyond, one of the papers does not have a calculator. Now, as I understand that paper, the arithmetic shouldn't be too difficult. However, I do think it is useful for you to be able to practice hard arithmetic and to become more comfortable with doing that. And there are techniques that make your life a lot simpler. So I'm also hoping to show you how to do that as well, so that, even, for example, if you go into the calculator paper and calamity strikes and your calculator breaks or runs out of battery or whatever, you should still be able to make a good headway and not lose too many marks. Okay? All right, guys, I'll see you in the next question. Okay, question 6. We've got a polynomial here where a, b, and c are integers. It is given that p prime of 0 is 12. It is also given that x plus 3 is a factor of p. And also when p is divided by x minus 1, the remainder is 16. So find the values of a, b, and c. Okay, well, let's take each of these 3 statements in turn. I'm going to take the first one, so p prime of 0. So that means I've got to differentiate this function first. So p prime of x. So I'm going to get 3ax squared 22x plus b. And then I want to find p prime of 0, right? So p prime of 0 means I substitute 0 into here, which means I'm going to get 0 plus 0 plus b. And we're told that that's equal to 12, right? So therefore, b is just equal to 12, right? Because p prime of 0 is b, and if it's equal to 12, then b is 12. Okay, second part. It is also given that x plus 3 is a factor of p. Okay, so we need to know the factor theorem, and we're also going to need to know the remainder theorem as well. So factor theorem. Okay. If x equals alpha is a root of the polynomial of f of x, then it follows that x minus alpha is a factor of f of x. Okay. And secondly, the remainder theorem. If we get remainder, sorry about my handwriting, remainder r when we divide f of x by x minus beta, let's say, then f of beta is equal to r. Right, sorry about that. Sorry if I'm using Greek letters. Sorry, it's just force of habit because I do it from A levels, right? Beta, just call it b, right? So if we get a remainder of r when we divide our polynomial by x minus b, then what that means is if I substitute b into the polynomial, I will get the remainder. Okay, so what's that actually mean in this particular question? It means that for this statement, right, if x plus 3 is a factor of p, then it means that negative 3 is a root of p, right? So negative 3 is a root, which means if we substitute negative 3 into the polynomial, we will get 0. The last statement, if p is divided by x minus 1, the remainder is 16. What does that mean? It means that if I was to substitute in 1 into the polynomial, I will get 16. That's the remainder theorem. So I'm going to go over here and I'm going to do that for both these statements. Statement 1 basically means that p of -3 will be equal to 0, right? That's the factor theorem. And the last one is p of 1 will be equal to 16, right? So if I was to summarize those two statements, statement 2 and statement 3, it will be these two statements here. So now what I've got to do is just got to substitute in. So if I substitute in -3 into the polynomial, then what I'll get is -27 a, beg your pardon, -27a, plus, so -3 squared is +9, so plus 99, plus b times -3, right? Now b was what? B was 12. So -3 times by 12 is -36, plus c is equal to 0. Okay? And if I was to simplify that, then I would get -27a plus c plus 63 is equal to 0. Okay, so that's one equation there. Okay, so the second equation, right, p of 1 is equal to 16. Just bring it down. P of 1 is equal to 16. So let's substitute 1 into our polynomial. So 1 cubed is just 1, isn't it? Right, so I get a plus 11 times 1 plus b, which is 12 times 1, plus c, which is equal to 0. Equal to 16, do beg your pardon. And so therefore I get a plus c is equal to, okay, 11 plus 12, that's what, 23. So I'll subtract the 16 from both sides, so that should be plus 7 is equal to 0. Okay, so I think hopefully all of that's okay there. So then I've got two equations, right, and I've got two unknowns. So here's equation 1, here's equation 2. I think probably the easiest way to deal with this is just to do a straightforward subtraction so that I can eliminate the c's. So -27a minus a is -28a. So -28a. C minus c is 0. And I've got 63 minus 7, which is 56. So that becomes plus 56 there, is equal to 0. So that means that 28a is equal to 56. And that means that a is equal to 2. And if a is equal to 2, I can substitute that into equation 2, right? So 2 plus c plus 7 is equal to 0. So c is going to be equal to -9. Okay, now let me just read the question again, see if there's anything else I need to do. I just got to find the values of a, b, and c, right? Okay, so my final answer is going to be a is equal to 2, a is equal to 2, b is equal to 12, and c is equal to -9. And I will just check that against the mark scheme. Let's make sure that everything is correct. A is 2, c is -9, and b is equal to 12. Yep, that's all correct. All right, then, here we are in question 7. When e to the 5y is plotted against x cubed, we get a straight line passing through these 2 points. Find y in terms of x. Okay, well, if we've got a straight line, all straight lines are in the form y is equal to mx plus c. Okay, and I've written big Y and big X here because in this case, right, the big Y represents e to the 5 little y, and the big X represents x cubed, right? So essentially, we're told that if we plot e to the 5y against x cubed, right, then we get a straight line. So e to the 5y here, x cubed here, in the form y equals mx plus c. Okay, so essentially what's the question really about? We want to find the gradient m, we want to find the y-intercept c. So that's what we're going to do. So how can I find the gradient m? Well, m is equal to y2 minus y1 over x2 minus x1, right? So y2 minus y1 over x2 minus x1. So we are going to get 9.84 minus 4.38, all divided through by 6.54 minus 2.56. Okay, and I will key this into a calculator. So we'll just get the top. Okay, 5.46 on the top. And on the bottom, 9.1. And so now if I do the division, I get 0.6. Okay, so 0.6, or if I prefer, 3/5. Okay, all right then. So we know that we've got the form y equals mx plus c, don't we? So I can now write and say that y is equal to 0.6x plus c, okay, because the gradient is 0.6. So now what I want to do is I want to find this y-intercept c, and how can I do that? Well, I can just substitute in one of these points. So I'll substitute in this point here. So 9.84 is equal to 0.6 times by 6.54 plus c. Okay, so let me try to do that. So 0.6 times by 6.54, and then I do 9.84 minus that, which gives me 5.916. So c is equal to 5.916. But everything else has been given to three significant figures. So I'm going to write that as 5.92. Okay. All right. So now we've got our equation, don't we? In the form y equals mx plus c. So y is equal to 0.6x plus the c, 5.92. And of course, what did we say? That the big y in this case is e to the power of 5y. And the big x is x cubed. Okay, so I want to write y in terms of x. What am I going to do? Well, I'm going to take the natural log of both sides. So I rewrite it in logarithmic form. So 5y equals the natural log of 0.6x cubed plus 5.92. And therefore, y is just going to equal to a fifth of that, right? A fifth of the natural log of 0.6x cubed plus 5.92. Okay, and that should be our answer. We've got part B. We want to find the values of x for which y can exist. Well, essentially what we've got to realize is that the number inside the logarithm always has to be greater than 0, right? So essentially, this thing here, 0.6x cubed plus 5.92 must always be greater than 0. And so therefore x cubed, it must be greater than negative 5.92 over 0.6. And then we will just have to cube root that, won't we? So 5.92 divided by 0.6, okay, is 9.866, right? So x cubed is greater than negative 9.87, I guess. And then let's cube root this. So that gives me 2.14, I think. So let me just put that in. Okay, so x is greater than negative 2.14. Okay, so I'm just going to check my answers against the mark scheme. So part A, a fifth ln, yeah, that's okay. And negative 2.14, yeah, that's also okay. All right, so we got right answers there for that. Okay, question 8. This is essentially an integration question, but before I do it, let me just try to explain the theory, I think, just for a second. If I have got a function, let's say the function is f of x, and I differentiate it, I get f prime of x, right? And if I differentiate it again, I get f double prime of x, right? So the key thing to notice is that if I differentiate, I'm going down, right? So I differentiate f of x, I get f prime. And if I differentiate f prime, I get f double prime. Well, how would I then go from f double prime back up to f prime, or from f prime back up to f? Well, I would have to integrate. Why would I have to integrate? Because integration is the reverse of differentiation, right? So basically, if I differentiate to go down, I integrate to go up, okay? So that's what's going to happen over here. So I've got f double prime of x. So how do I get f prime? Well, f prime of x will be equal to the integral of f double prime, All right, so I'm going to be integrating 3x plus 5 to the power of negative 2/3 dx. Okay, so how am I going to integrate that? Well, the first thing is I've got to raise the power by 1. So negative 2/3 plus 1 is positive 1/3. I've then got to divide by that power. So dividing by 1/3 is the same as timesing by 3. And then I've got to look at the coefficient of the x, which in this case is 3, and I've got to divide through by 3. Okay, so let me just go through those steps again, right? You take this power, you increase it by 1, you divide by that new power, you then take the coefficient of the x and you divide by that. However, I need to remember to include here the constant c, okay, because I've got an indefinite integration, and so therefore I need to include the constant. Now, of course, we know that 3 divided by 3 cancels off, so we're just left with that. Now, what are we told? We are told that f prime of 1 is equal to 6. Okay, so what I've got to do, I've just got to substitute 1 into this function, and it will be equal to 6. So 6 will be equal to 3 times by 1, which is 3, plus 5, which is 8. So 8 to the power of a third, plus c. And 8 to the power of a third is 2. So 6 is equal to 2 plus c. So c is equal to 4. So let's rewrite this. We now know that f prime of x is equal to 3x plus 5 to the power of a third plus 4. Okay, so we got f prime. How can we then find f of x? Well, f of x is going to be the integral of f prime. So I've got to integrate 3x plus 5 to the power of a third plus 4 dx. And so if I integrate this, it's going to be the same rule, right? So I've got to add 1 to the power. So a third plus 1 is 4/3. I've got to divide by 4/3, which is the same thing as timesing by 3/4. And I've got to take the coefficient of x, which is the 3, and I've got to divide by 3. So I divide by 3. And of course, those 3's are going to cancel off. And I then got to remember I've got to integrate the 4. I've got to integrate this 4. If I integrate that 4, I'm going to get 4x. And then I've got to have another constant of integration, which I'll call k, because, yeah, again, I've got an indefinite integral. Okay, now if I go back up to the question, I am told that f of 1 is equal to 20. So what does that mean? If I substitute 1 into the function, I'm going to get 20. So let's just go down. Okay, so if I substitute 1 into this, I should get 20. So let's do that. So I get 20 is equal to a quarter of 3 times by 1, which is 3, plus 5 is 8 to the power of 4/3, plus 4 times by 1, which is 4, plus k. Okay, what does the power of 4/3 actually mean? It means that I've got the cube root of 8 all to the power of 4. Right, so that's what the power of 4/3 means. The denominator is the roots and the numerator is just an ordinary power. So the cube root of 8, right, is 2, and 2 to the power of 4 is 16. So I've got 16 times by a quarter, so 16 divided by 4 plus 4 plus k. And 16 divided by 4 is 4, plus 4 is 8. So what do we got here? We have got 20 is equal to 8 plus k, so k is equal to 12. Okie dokie, well then that means that I can now write my function out in full. F of x is equal to, what was it? A quarter of 3x plus 5. All right, so a quarter of 3x plus 5 to the power of 4 upon 3 plus 4x plus 12. And I will just check my answer to see if that's all okay. Where is it? Yeah, that's all correct. Okay. All right, guys. So I think a bit of patience there. That shouldn't be too difficult, but you just got to be extra careful that you don't fall into any of the traps, like forgetting the constants of integration. All right, question 9. The equation of a curve is this thing here, where x is less than -1. show that dy dx is equal to this, where a and b are integers to be found. Okay, right. Well, this probably looks quite scary. But the first thing you really got to notice is that you've got one function divided by another function. And when you've got one function divided by another function, you need to use the quotient rule. Okay, so what is the quotient rule? Quotient rule is if y is equal to one function u divided by another function v, then dy dx is equal to v times by du dx minus u times by dv dx all over v squared. And the most common error is to get the order of these guys wrong, to write u dv minus v du. And the reason you do that is because that's the order in which you've memorized the product rule. Okay, so what I suggest is you change the way you memorize the product rule so that it's in the same order so you don't make that mistake. All right, so if we're going to do this, how are we going to do? Our u is e to the power of negative 3x plus 2. Our v is equal to x plus 1. X plus 1. So firstly, I've just got to differentiate these two guys. So u prime, if I differentiate e to the negative 3x plus 2, the e remains the same, right? I've still got e to the negative 3x plus 2. But what I've got to do is I've got to differentiate this power. So if I differentiate that, I get negative 3, and I times through by negative 3, right? Basically, what I've done there is I've done a chain rule, right? Because I've got one function, the negative 3x plus 2, inside the exponential. So how do I do that? Well, I differentiate the big function e, which remains the same. And then I've got to differentiate the smaller function, negative 3x plus 2, which gives me negative 3, and I multiply through by that. By far the most common error with this is students seem to think that they are differentiating like x to the power of 5, which becomes 5x to the power of 4. And so therefore they'll write something a bit mad like negative 3x plus 2 times by e to the power of negative 3x plus 2 minus 1, right? Because they think they're differentiating it in the same way, which is, you know, you bring the power down to the front and you subtract 1 from the power. But that's not true because that's not how you differentiate an exponential. Okay, so if you're the kind of person who makes that mistake, you need to kind of stop and pause and remember that this is actually a different function here. All right, next part, if we differentiate x plus 1, right? If I differentiate x, I get 1. If I differentiate 1, it's a constant, so I get 0. So now what I've got to do is we've got to substitute in really into our function for the quotient rule. So I got v du, so I got x plus 1 times by this thing here, right? So negative 3 e to the negative 3x plus 2. So it's v du minus u, which is e to the negative 3x plus 2 times by dv, which is 1. Okay, so it's not too bad. And then we've got to divide that through by v squared, which is x plus 1 all squared. All right then, now I seem to notice that we have got a common factor here of e to the negative 3x plus 2. And so what I'm going to do is I am going to factorize that out. So I get e to the negative 3x plus 2, big bracket. I'm going to have negative 3 times by x plus 1 minus 1, right? So if I factorize out the green thing from this term, I'm just left with negative 3 times x plus 1. If I factorize out the green thing from this term, I'm just left with negative 1, right? So that's what's happened there. All divided through by the x plus 1 squared. X plus 1 all squared. Okay, let me just check the way they want us to get it. Yeah, all right, okay, fair enough. So I now just got to simplify this bracket, right? So I got negative 3x, and I got minus 3, minus 1 is minus 4. So this guy is going to become minus 3x minus 4 times by e to the negative 3x plus 2, all divided through by x plus 1, all squared. Now I think that's probably, yeah, the form that we're asked to give it in. So I think therefore that the a is going to be what, negative 3, and the b is equal to negative 4. So I'm just going to check the answer against the mark scheme, make sure that I have got it right. Where have we got? Yeah, negative 3 and negative 4. Okay, so we're all happy with that. Let's go to the next part. So hence show that there is only one stationary point on the curve and find its exact coordinates. Okay, so what is a stationary point? A stationary point is where dy dx is equal to 0, right? So a stationary point is when y prime is equal to 0. Now, if you're not sure about why that is, like what does that actually mean? A stationary point, right? If I've got a curve that looks something like that, so that's a negative cubic kind of shape. The stationary points are here. That's the minimum, and that's like a local maximum, right? Minimum, maximum. If I was to take the gradient at this point, right, I get a flat line, don't I? Because what's happened is I've gone from a negative gradient to a positive gradient, so the gradient here is 0. And the same thing with this guy. The gradient here is also going to be a flat line. So the gradient will be 0 because I've gone from positive gradient to negative gradient, so that gradient there is 0. So every time I've got a stationary point like this or like this, the gradient is 0, so dy dx is 0. Okay, so let's put that in. We're basically saying that negative 3x minus 4 times by e to the negative 3x plus 2 over x plus 1 all squared must be equal to 0 to get a stationary point. Well, we can get rid of the x plus 1 squared, right? So immediately we get negative 3x minus 4 times by e to the negative 3x plus 2 must be equal to 0. Okay, so we get through with that. So let's have a quick think about what this actually means, right? We've got two terms. We've got this term here, negative 3x minus 4. That's one term. And we've got another term here, the e to the negative 3x plus 2. And those two things multiply together to give us 0. Now, how can that be? Well, just take a step back and say, if I've got 5 times 0, right, what do I get? I get 0. And let's switch it around. If I've got 0 times by 3, what do I get? I get 0. So if I've got any two numbers that multiply together and the answer is 0, then one of those numbers must be 0. So what I've got is either this thing must be 0 or this thing must be 0. So I'm going to write down now, I'm going to say, okay, negative 3x minus 4, either that thing is equal to 0, or alternatively, e to the negative 3x plus 2 is equal to 0. Okay, so that's what I've got. Now then, this guy on the right can never be equal to 0. It's not possible. And partly the way we can think about that is we can just think very quickly about the exponential graph, right? What does an exponential graph look like? Okay, so I'll draw a positive exponential here because the same is true for a negative. It looks like that. Oh, sorry, not with the kink in it. And basically, an exponential is never, ever, ever equal to 0. It's not negative either, and it's never equal to 0. It gets very close to 0, but is never equal to 0. So there is no value of x where this is true. And if you want to confirm that even more, what you could do is you could use your calculator, right? And you can say, all right, okay, I'm going to say that negative 3x plus 2 is equal to ln 0. And then when you put ln 0 into your calculator, you get math error. So what does that mean? Math error means there's no solution. Why? Because ln 0 doesn't exist. So then what we've got is we're going to instead get that negative 3x is equal to 4, which means that x is equal to negative 4 upon 3. So that's going to be the only x coordinate of our stationary point. So we're going to want to get the y coordinate too. And the y coordinate is I've got to substitute it into this thing here. All right, so negative 3x plus 2, okay. So y is equal to e to the negative 3 times by negative 4 upon 3 plus 2 over, what was it, x plus 1? X plus 1, so negative 4 upon 3 plus 1. So what's going to happen there? Well, the 3's cancel, right? So I'm left with positive 4 plus 2, which is e to the power of 6. And then negative 4/3 plus 1, right, is plus 1 is the same as adding 3/3. So negative 4/3 plus 3/3 is negative 1/3. And so that guy is actually equal to negative 3 e to the power of 6, because dividing by a third is the same as times by 3. So the coordinate, I think, is going to be negative, what was the x coordinate? Negative 4/3? Negative 4/3, comma, negative 3 e to the power of 6. I think that should be right. And I will just check the mark scheme to confirm that I'm right. and I am right. Okay, happy day. That's very good. Okay, yeah, that's quite hard, that one. Requires a little bit of patience, but hopefully I think everyone should be able to do the quotient rule at least. And you need a little bit of thinking skill to get through to the end of the stationary point one, but yeah, with a little bit of reason, hopefully shouldn't be too bad. Okay, question 10, a arithmetic geometric progression style of question. So we've got the third and the eighth terms of a geometric progression are 6 and 1, 4, 5, 8. Find the common ratio and the first term of the progression. Well, this should be fairly straightforward, right? For a geometric progression, the nth term is equal to a times by r to the power of n minus 1, right? Where a is the first term, r is the common ratio. So the third term is going to be ar to the power of 2, and that's equal to 6. And the eighth term will be ar to the power of 7, and that's going to be equal to 1, 4, 5, 8, right? So we've got two equations here, right? Equation 1, equation 2. So what do we actually want to do? We're going to do equation 2 divided by equation 1. So we're going to get ar to the power of 7 divided by ar to the power of 2 is equal to 1, 4, 5, 8 divided through by 6. So we can cancel off the a's, right? And we can divide through by r squared, which makes that r to the power of 5. So what we're left with then is r to the power of 5 is equal to 1458 over 6. Okay, let's say that you didn't have a calculator, right? So you're not too sure how to do that. Well, 1400 divided by 2 is 700, isn't it? And then we got 58. We want to divide that by 2. That's going to be 29, okay? And then what we want to do is we want to divide that further by 3. How would we do that? Well, 700 doesn't divide by 3, but 600 does, right? So if I divide 600 by 3, I'm going to get 200, and that leaves me with 129. 120 divided by 3 is 40, right? So we've got 240, and then 9 divided by 3 is 3, okay? So just, good to practice being able to do the divisions in case your calculator doesn't work or you don't have a calculator. Okay, so then r is going to be the fifth root of 243, and that's going to be equal to 3. I think you should know that, I guess. I know it's a little bit difficult, but you should know the powers of 2 and powers of 3, right? So 3 to the power 1 is obviously 3. 3 squared is 9. 3 cubed is 27. 3 to the power 4 is 81. And then the next one is going to be 243. Okay, so I think you probably should be able to recognize that, but if you're really not sure, of course, you've got a calculator. And in this kind of question, you're reasonably confident it will be an integer. Okay, so we've got r. What we need to do now is we need to find out what a is. So ar squared is equal to 6. So a times by 2 squared is equal to, sorry, not 2 squared, 3 squared, beg your pardon, because r is 3, is equal to 6. So a is equal to 6 divided by 9. And 6 divided by 9 will be 2/3. Okay, so I'm just going to quickly check my answer, make sure that that is correct. So we've got 3 and 2/3. Yep, 3 and 2/3 is correct. Okay, so we're going to move on to part B of this question. Okay, the first three terms of a second geometric progression, so it's a different one here, are cos theta, 2 cos squared theta, and 4 cos cubed theta, where theta is between negative 90 and positive 90. Find the values of theta for which this geometric progression has a sum to infinity. Okay, now this is quite a harder question. They've asked it now a few times in the last couple of years, so I think you need to understand this. What is a sum to infinity? Well, basically, if we've got a progression which is like this, so let's imagine we've got 4 plus 2 plus 1 plus a half, plus a quarter, plus an eighth, right? And it keeps on going on and on and on. Now, what do you notice about this? This is a geometric progression where the ratio is equal to a half, which means that every other term is divided by 2, right? So 4 divided by 2 is 2, divided by 2 is 1, divided by 2 is a half, and so on and so on and so on. Now, the key thing about this, right, is that this particular geometric progression, all the terms are getting smaller and smaller and smaller and smaller, until eventually, somewhere over here, right, these terms are getting so small that they're almost equal to 0. And so if you imagine that you are doing this addition, right, you're adding up all of these terms, eventually what you're going to be doing is you're going to be adding 0 plus 0 plus 0 plus 0. Well, when you're adding 0, your expression, your sum, isn't going to get any bigger. So we refer to that as the limit And that limit is what we call the sum to infinity, right? So the sum to infinity basically happens because when we add up all of these terms and just keep on going, never, 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 never stop, if the terms are getting so small that they're almost zero, then this summation can carry on forever. It doesn't really matter. It's just going to reach a fixed limit. And the limit in this case will be the number 8. Okay, so then what is the condition for that to happen? Well, the condition for that to happen is that each term has got to get smaller. And for each term to get smaller, the common ratio has to be between 1 and -1. Now, if you just think about that just for a second, right? If the ratio was like 2, then all the terms are going to be getting bigger, right? If the ratio was 3, all the terms would be getting bigger. Similarly, if the ratio is like -2 and -3, okay, the terms become positive, negative, positive, negative, positive, negative, but the terms are still like getting bigger in size, right? So you know, if we were to have a different sequence, like, I don't know, 3 minus 6 plus 12 minus 24 plus 48, right? These values are getting bigger and bigger and bigger. So if I kept adding them forever and ever, I'm not going to reach a fixed limit. It's just going to keep growing and growing and growing. So instead, what we require is, if the terms are going to get smaller, then we need to satisfy this condition. The common ratio, the absolute value must be less than 1, which is the same as saying it must be between -1 and +1. Okay, so sorry that's quite a long explanation of the basic theory, but often what happens is I find that students can't do this because they don't actually really understand what's going on. So I hope that you can actually understand it, because if you can understand it, it makes sense and it shouldn't be that hard. Okay, so we want to find the values of theta basically where the common ratio is between -1 and +1. What is the common ratio going to be? Well, the common ratio we can find by taking any two terms and dividing through, right? So I can take the second term and divide it by the first. And if I do that, I just get 2 cos theta, right? So the common ratio is 2 cos theta. So what do I actually require? I require that 2 cos theta must be between 1 and -1. And that means that cos theta must be between 1/2 and -1/2. So basically what I want to do is I want to find the values of theta such that cos theta is between -1/2 and +1/2. Well, how can I do that? I think the best way is to draw a quick graph. Okay, if I draw a graph, this will become kind of more straightforward. So here is my, here's my cos graph. So whatever, this will be like 90 degrees and -90, 180, whatever. Okay, and this is 1 and -1. Now we know that the cos graph starts at +1, right? So the graph will look something like that, like that, like that, that. It goes down to -1. Okay, and like that. Okay, so that's the graph of cos theta. Now, what do we want? We want this cos theta to be between 1/2 and -1/2, right? So we can just draw a line through y is equal to 1/2. Let's do that a bit better, I think, like that, and -1/2. Right, so there we go. That's our 1/2 and -1/2. So we want to find the values of cos theta which are in those boundaries, which are going to be these values here and these values here, right? So I can like shade in the parts that I'm interested in. I want these values, okay? But hang on, if I read the question very carefully, I'm also told that theta is between -90 and +90, right? So in other words, my theta values can only go from here all the way up to here. So actually, I'm not even interested in this part of the graph, so I can just get rid of it, right? So that goes, all of that, not interested, because I just want to be between 90 and -90, so all of that goes. So in essence, all I'm left with is with those little red bits there that I want to find, right? So I want to find that. So what's that going to depend on? Well, I just got to find out what that value is of theta there. So I'm going to do the cos inverse of 1/2, right? And if I do the cos inverse of 1/2, I should get 60 degrees. So that value there is 60 degrees. And by symmetry, right, that value there is going to be negative 60 degrees. So what values of theta can I have? Well, I can have anything from negative 90 to negative 60, and I can have anything from positive 60 to positive 90. So I can then say, okay, my condition must be theta is greater than negative 90 and less than negative 60, or theta is greater than positive 60 but less than positive 90. Okay, so I like that question because I think it really sort of does test the student's analytical skill. It is definitely not easy, right? But, you know, it's one of those questions where if you understand what's going on and you're reasonably confident and you can sort of piece things together, then I think it should be okay. All right, but the key thing is always you want to try to understand. And so what I would suggest is that you make a start by really trying to understand why the common ratio must be between 1 and negative 1. And I would probably try to build on that by thinking, am I confident using the graphs of sine and cosine to solve problems like this? Okay, so I think that those are probably the areas which will require a little bit of work. Okay. Okay, then question 11. So the diagram shows part of the curve 4 plus 2 sine 3x, so that's that curve there, and the straight line A to B. The points A and B lie on the curve. The x-coordinate of A is pi by 18, the y-coordinate of B is pi by 3. Find the area of the shaded region, giving your answer in exact form, right? So we want to find this area here. Okay. Now, students tend to think that this kind of question is an integration question, and they are right to think that. However, before you actually start to integrate, you want to think a little bit more big picture, right? You want to think, I'm actually trying to find an area here. So what are the areas that I need to find in order to get this shaded region? Well, I could think of it as finding the area underneath the curve, which is this whole big thing here, right? That region there. And then subtracting away from it the area of this trapezium, right? So I break down the problem into two parts first. And part of that doesn't even need to do any integration, right? So let's start by trying to find the area of that trapezium. What would I need to do that? Well, I would need to know the height of this and the height of that. And that's going to be given by the y-coordinates of A and B respectively, right? So I can find the y-coordinate at the point A by asking when x is equal to pi by 18. So I'm going to substitute that into the curve, and I will get y is equal to 4 plus 2 sine 3 times pi by 18, which is going to be pi by 6. And what is pi by 6? It's a half. What's sine pi by 6? It's a half, right? So I'm going to get 4 plus 2 times a half, which is 1. So the y-coordinate there is going to be 5. Okay, so this value here, that value is 5, right? Which means that this length here critically is 5. Okay, all right then. What about B? Right, so B, when x is equal to pi by 3, y is going to be equal to 4 plus 2 sine 3 times pi by 3, which is pi. And sine pi is going to be 0, so I'm going to be left with 4. So the y-coordinate of B is 4, which means that this length here is 4. Well, that immediately means that I should be able to find the area of the trapezium, right? Because what's the area of a trapezium? So area trapezium, it's equal to a half of these two lengths added up. So half of 5 plus 4 times by the width, right? So the width is going to be pi upon 3 minus pi upon 18. Okay, so 5 plus 4 is 9. So I've got 9 upon 2 times by, okay, well, pi by 3 is the same as 6 pi upon 18. So minus pi upon 18 is 5 pi upon 18. And then I can cancel, can't I? I can divide top and bottom by 9. So that should give me 5 pi upon 4. So the area of trapezium there is 5 pi over 4. Okay. All right then, so now what I can do is I can find the area underneath the curve, I think. And how am I going to find the area underneath the curve? Well, I'm going to integrate the curve between the two values of pi by 18 and pi by 3. So let's just go over here. So the area under curve is going to be equal to the integral of, what was it? 4 plus 2 sine 3x and integrated between pi by 18 and pi by 3. And so then if I was to integrate this, right, 4 integrates to give 4x. And how does sine integrate? Well, sine integrates to give negative cos, right? And the reason we know that is because cos differentiates to give negative sine, right? And differentiation is the reverse of integration and vice versa. And then what have I got to do? Well, I've got to take the coefficient of the x, which is 3, and I've got to divide by 3. So I end up with minus 2/3 cos 3x. And I'm integrating that between the bounds of pi by 3 and pi by 18. So now let's substitute in, I think. So we substitute in the upper bound, so we get 4 pi upon 3 minus 2/3 of cos 3 times by pi by 3, which is going to be cos pi. And then if I substitute in the lower bound, I'm going to get 4 times by pi by 18 minus 2/3 of cos 3 times by pi by 18, which is pi by 6. So now I'm just going to very slowly, very carefully simplify all of this. This is 4 pi upon 3 minus, now cos pi is -1. So we're going to get negative 2/3 times by -1. So that's going to be positive 2/3. Minus, I'll simplify this to be 2 pi upon 9. And then plus 2/3. Now what's cos pi by 6? Cos pi by 6 is going to be root 3 upon 2. Okay, because it's cos 30 degrees. So now hopefully I can simplify this a little bit. So 4 pi upon 3 is the same as 12 pi upon 9 minus the 2 pi upon 9 plus 2/3. I can cancel off the 2's here, right? So plus root 3 upon 3. And so therefore, what I'm going to get is 10 pi upon 9. Okay, so 10 pi upon 9 plus 2/3 plus root 3 upon 3. Okay, so that's the area under the curve. So what's the total area going to be? Well, the total area is going to be the area under the curve minus the area of trapezium, right? So the total is, I've just got to subtract off the 5 pi upon 4. So let's just go down here. So total is equal to 10 pi upon 9 plus 2/3 plus root 3 upon 3 minus 5 pi upon 4. Hope I got that right. Yeah. Okay, so then I just got to simplify the fraction. So what's the lowest common denominator of the 9 and the 4? I think it's going to be 36, isn't it? Right. So I'm going to times this one by 4. So 40 pi upon 36 plus 2/3 plus root 3 upon 3 minus 45 pi upon 36. And so then if I simplify all that, that's going to be 2/3 plus root 3 upon 3 and minus 5 pi upon 36. Okay, and my answer, I think, needs to be in exact form, according to the question. Yeah, give our answer in exact form, so that should be it. So let me just check the mark scheme, see if that is the right answer. So question 11, 2/3 plus root 3 upon 3 minus 5 pi upon 36. And that is the right answer. Okay, quite a lot of work there. But with these kind of questions, right, as I said in the beginning, it is an integration question, but don't think of it that way first. Think of it as a area question, right? What areas do I need? And break down the problem that way, right? So you need to find the area of trapezium. Okay, so I need to find the heights of the trapezium. So I need to find the y coordinates of A and B. So you can do all of that work first, right, before you ever do any integration. You can pick up lots of marks that way. And then right at the very end, you can do your integration and then piece it all together. Okay, I hope that was helpful. Okay, then question 12. You've got some quite difficult trigonometry questions here. So we're supposed to solve the equation 2 cosec squared theta minus 5 is equal to 5 cot theta between negative 180 and positive 180. Now, I think really in order to be able to do this, there are a couple of ways, but the simplest way is to check the identities that are given in the front of your exam. And one of those identities is that cosec squared is equal to 1 plus cot squared, right? So I'm going to write that down. So cosec squared theta is equal to 1 plus cot squared theta. So that's in the front of your exam. And I think that if you're in one of these questions and you see like a sine squared or a cos squared or a cosec squared or a sec squared, you want to just quickly double check those formulas to see if there's anything that can make your life easier. Because in this case, what we've got, if we substitute in, is we've got 2, 1 plus cot squared theta minus 5 is equal to 5 cot theta. And so if I was to rearrange this, right, I've got 2 plus 2 cot squared theta minus 5 is equal to 5 cot theta. And that becomes 2 cot squared theta minus 5 cot theta minus 3 is equal to 0. And this is a hidden quadratic, isn't it? If we want to make it super duper duper clear, we can just say let u equal cot theta. And if we do that, we're going to get 2u squared minus 5u minus 3 is equal to 0. And hopefully that should factorize quite nicely to give us 2u and a u. Okay, and I want two numbers to multiply together to give negative 3. So I think that's going to be negative 3 there and positive 1. Right, because positive 1 times negative 3 gives negative 3. If I do negative 3 times positive 2, I get negative 6u plus 1u is negative 5u. So I end up with two answers. Either u is equal to negative a half or u is equal to positive 3. And of course, what is u? U is cot theta, isn't it, right? So cot theta is equal to negative a half, or cot theta is equal to 3. Now, what is cot? Cot is the same thing as 1 divided by tan. How can we remember that? We look at the third letter, right? 1, 2, 3. Third letter is T. So this is 1 divided by tan. Like in the same way that sec, right? The third letter is C. That's 1 divided by cos. And cosec, the third letter is S. So that's 1 divided by sine. So you get 1 upon tan theta is equal to negative half. 1 upon tan theta is equal to 3, which means that if we were just to invert this, we will get that tan theta is equal to negative 2, and we've got tan theta is equal to a third. Okay, so then how can we solve this? Well, we could do the tan inverse, right? So we do tan inverse of negative 2. So yeah, tan inverse of negative 2 gives me negative 63 degrees. Am I using degrees or am I using radians? I'm using degrees, okay? So that gives me negative 63.4 here. And what about for this guy? If I did the tan inverse of a third, so the tan inverse of a third is 18.4 degrees. Now the thing is, we need to be super careful with these questions because we're asked to find all the solutions between negative 180 and positive 180. Now, what is the period of the tan wave? The period of the tan wave is 180, right? So I can take each of these solutions and I can add 180 or I can subtract 180 and I'm going to get another solution. So this guy here, if I subtract 180, it's going to be too big or too far out, right? It'd be like negative 240 something. So I can still take it and I can add 180. Which gives me 116.6. So 116.6, okay? And the same thing with the 18.4, right? If I was to add 180 to that, that would be too big. You get like 198. But if I subtract 180, if I go back a period, I'm going to get negative 161.6 degrees. So I think what we should have is we should have 4 solutions there, beg your pardon. And I'm just going to quickly check the mark scheme, see if those are indeed the right. So negative 161.6, negative 63.4, 18.4, 116.6. Yep, that is totally correct. Now, if you're not sure about what's happened there, I suggest that we just think about the graph of the tan wave, right? So I love graphs, as you probably know if you've watched any of my videos, and I think that actually if you learn how to graph, your life becomes a lot easier. What does the tan wave look like? Basically, the key to drawing it is to realize it goes between asymptotes at negative 90 and positive 90, right? So I get these asymptotes here. So boom, 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 boom. And there, like that. And the wave itself kind of looks like this. It goes up like that. I'm trying to draw it as neatly as I can. Okay, yeah, that's good enough. And essentially this wave repeats every 180 degrees, right? So the period of the tan wave is 180, unlike the period of the sine and cosine, which is 360. So this guy kind of comes up like that, and over here, right, like that. Okay, now then, we are asked to solve where tan theta is equal to -2. So what does that actually look like? Tan theta is equal to -2 may look something like that. All right, so this is a horizontal line where y is equal to -2, beg your pardon. And we also want to solve it where tan theta is equal to 1/3. So what would that look like? Like another horizontal line through y is equal to 1/3. So maybe draw it like that. Okay, so that's y is equal to 1/3. So our solutions on the calculator, right, would be this guy and that guy. So for -2, that corresponds to -63.4, right? So that solution there would be like -63.4. And this solution here would be, what was it, 18.4. Well, how can I go from this solution to the corresponding solution on the next wave? Well, I've just got to add 180, right? Because I'm moving one wave to the right. So I add 180. How can I go from this solution here to the corresponding solution on the right? Well, I add 180. Or let's say I was here and I wanted to find the solution to the left. Well, I would have to subtract 180 because I'm going one wave to the left, right? So that's the idea of what's going on. The key fact is that the period of the tan wave is 180 degrees. And so I can add and subtract 180 to my solution to get the next solution along. Okay, I hope that was helpful. If you are finding these videos helpful, by the way, please like and subscribe. All right, then the last question, we want to solve the equation 3 sine 2 phi plus 1.5 is equal to 2 for phi is between 0 and 5. Where phi is in radians. Okay, so how do I usually do this? Well, if we've got anything unusual in the sine or cos or tan, I tend to write this as a substitution. So that is exactly what I'm going to do here. I'm going to say let u equal 2 phi plus 1.5, which I'll write as 3/2. And I might as well just rearrange that as well at this stage. I think that's a helpful thing to do. So 2 phi will be equal to u minus 3/2, which means that phi is equal to u minus 3/2 divided by 2. Or alternatively, we could write that as 2u minus 3 over 4, right? I've just multiplied top and bottom by 2 there. Okay. All right. So I've done that. Now, why have I done that? Well, it enables me to do a couple of things which I think will make my life easier. So the first thing is I can rewrite this as 3 sine u is equal to 2. So I'm gonna do that. So 3 sine u is equal to 2, which means that I'm trying to solve now sine u is equal to 2/3. Okay, so I think that's an easier thing for us to solve. Because let's say we want to use the graph of sine u to help solve it, or we know what that graph looks like. That's kind of easy. Okay, it also helps us with this issue of the set of answers that we can have, right? Because sometimes students are not sure how far should I keep going to find my answers, and often they sort of guess. So we know that phi needs to be between 0 and 5. Well, what is phi? Phi is this thing here, isn't it? Right? So we now know that we actually want 2u minus 3 upon 4 to be between 0 and 5. So if I multiply everything through by 4, that means that 2u minus 3 must be between 0 and 20. And then if I add 3 to everything, that means that 2u must be between 3 and 23. And then if I divide by 2, that means u has to be between 3 upon 2 and 23 upon 2. Or if we prefer, 1.5 and 11.5. Okay, so 1.5 there and 11.5. So I know some of you may not like the way I've done this, but essentially what I'm trying to do is I'm trying to rewrite the question in a way that is a bit easier. We are now trying to solve this thing. Sine u is equal to 2/3 between these values, right? Where u is from 1.5 to 11.5. Now, there are two ways of doing that. I could draw the graph of sine u, or I could use the unit circle. Now, I'll draw the graph of sine u to be like the previous question, but I'll also try to go through the unit circle as well. So what does the graph of sine look like? Graph of sine looks kind of like this, right? So whatever that's pi by 2, pi, 3 pi by 2, 2 pi, and so on, right? So there, pi, 2 pi there. And it goes up to 1 and goes down to -1. And so the entire wave is going to look something like that. Goes up, comes down. Okay, like that. Goes down like that. Comes back up. Comes back up. Comes back down. And so on, right? So that's what it looks like. That's the graph of sine u. And we're trying to solve where sine u is equal to 2/3, right? So 2/3 is going to be this line here. So let's put that on. So there we go. We're trying to find where the graph is equal to 2/3. In other words, we are interested in this point here, this point here, this point here, and this point here. Okay, now, if we do sine inverse of 2/3 on our calculator, right? So 2/3 and then sine. Oh, you'll need to change my calculator radians. How do I do that? Yeah, got it. Okay, so sine inverse of 2/3 is 0.729. Okay, I just want to quickly double check what they asked for in terms of significant figures. Okay, so 2 dp or 3 significant figures. Okay, I'll do it like that. So this value here is 0.730, okay, to 3 significant figures. Okay, so we've got that value there. Now, how can we use that to find this value? Well, we can use the property of symmetry, right? The graph is symmetrical about pi by 2, okay, so that line there. And that means that this point is symmetrical with that point, and that point is going to be symmetrical with that point. That means that this distance from here to here, right, between 0 and 0.730, right, so that distance has got to be the same as this distance. So in other words, I can find this second point by doing pi minus 0.730, which is exactly what I'm going to do. So I'm going to do pi minus the answer, and I get 2.41, right? So 2.441. I'll take it at 3 dp for 1, 2. Okay. Okay. So I end up with these two kind of basic solutions. Now, how can I go from those two solutions to the next two and the next two? Well, this point here is essentially the same as that point. It's just on the next wave along, right? So if I move one full wave, I get onto this equivalent point here. And the same is true with this. If I move one full wave, I get to the next equivalent point there, right? So what I'm trying to say is that this point is one wave along, and this point here is one wave along. And for a sine wave, each wave has got period of 2 pi, right? So I'm going to take each of those solutions, and I'm basically just going to add 2 pi and add 2 pi. So, so I'm going to take my first solution, and I'm going to be adding 2 pi. So I get solutions are u is equal to 0.730, but if I add 2 pi, I get 7.013, and if I add another 2 pi, I get 13.296. Okay, if I add another 2 pi, I get 19.57, and that's already out of bounds, right? Oh, sorry, actually 11.5 was already out of bounds, so that solution is also irrelevant, right? So that solution is not needed because that's too big, and this solution is not needed because that's too small, right? Because I only want solutions between 1.5 and 11.5. Okay, what about my other values? Well, I've got 2.412, right? So 2.412, and then this guy here, I'm going to add 2 pi as well. And that gives me 8.695. So, okay, so I've got another solution of 2.412 and 8.695. Okay, and if I add 2 pi again, I would get 14.978. And again, that solution is too big, so that guy is discounted, right? So I've got these 3 solutions for u, and I know that those guys are correct because I've already worked out previously where u can go between. So then what's the last thing that I need to do? Well, I need to find my solutions for phi, don't I? And phi is 2u minus 3 over 4, right? So phi is equal to 2u minus 3 over 4. So I'm just going to take each of those values and I'm going to double them, subtract 3 and divide by 4. Okay, so let me do that. 7.013 times by 2 minus 3 divided by 4 gives me phi is equal to 2.7565. Okay, and then 2.412, so 2.412, if I times by 2, I subtract 3, and I divide by 4, I get 0.456. Okay, and then 8.695, okay, the last one, right, this guy. Okay, I'm going to double it. I'm going to subtract 3, and I'm going to divide by 4, which is 3.5975. Okay, so I think those should be my answers. Now I probably have to put them to 2 dp, I think, something like that. I just want to double check. So the solutions that I've got are 0.456. Yeah, that's one answer. 2.76, that's another answer. And 3.60. Okay, all right. So they want it, I think, to 3 significant figures. So you'd have to rewrite this as 0.456. 2.76 and 3.60. Okay, and that would be your answers in 3 significant figures. All right, guys. Now I know, right? I really do know that the way I've done it is very long, but it is meticulous, and it means that I'm getting it right. And the most important thing is I know that I'm getting it right. Okay, there's no kind of I'm not sure about what's going on. So the thing that I do with using the substitution, so changing the problem, and then also using the substitution on the domain of values, right? So I completely change the problem from a problem in phi to a problem in u. Okay, that's the first thing that I do. That takes time and effort, but I really think it pays off. The second thing I do in this case is I decide to draw a graph, okay? And the graph helps me to understand how I can get from my calculator the first value to then get the second value and the subsequent values. And then after that, right, I just work back and I try to go from my u values back to my theta by typing them into a calculator. It takes a little bit of time, but it does get the right answer. Okay, then. Well, I want to just quickly talk about how to do this using the unit circle. Okay, so what is a unit circle? Unit circle is the circle of radius 1, right? Because unit just means 1. So it's going to look something like this, okay? Sorry about that. It's a bit rough. Okay, yeah, something like that. Okay, so that's a circle of radius 1. So that's 1, negative 1, 1, negative 1. And the key fact is basically that sine and cosine come from this unit circle, right? So if we've got an x coordinate here and a y coordinate there, and this point makes an angle of theta with the positive x-axis, then this x coordinate is tells us cos theta, and this y coordinate tells us sine theta. So essentially, right, when we're saying to ourselves, like, what is cos theta and what is sine theta, what we actually mean by that is, for this particular angle of theta, let's say it's 30 degrees, what is the x coordinate on the unit circle? And when we say sine theta, right, it's like sine 30 degrees, we mean if theta is 30 degrees, what is the y coordinate on this unit circle, right? So cos theta means what is the x coordinate on the circle, and sine theta means what is the y coordinate on the circle. So, I mean, in the case where theta is equal to 30 degrees, let's say, the x coordinate is going to be root 3 upon 2, and the y coordinate is equal to a half. That means that cos theta will be root 3 upon 2, or sorry, cos 30 will be root 3 upon 2, and sine 30 will be a half. Now, when it comes to solving problems like the one that we've got, right, so we want to try to solve, what is it, cos u is equal to 2/3, I think it was. Let me just take you back. Yeah, cos u is equal to 2/3. How would we do that? Well, sorry, sine u is equal to 2/3. Do beg your pardon. Sine u is equal to 2/3. What is sine telling us? Sine is telling us the y coordinate on the unit circle. So in other words, what I want to do is I want to find where the y coordinate is 2/3. So I can draw a line through 2/3 like that, right? And essentially what I'm trying to do is I'm trying to find the angles that will give me those coordinates on the unit circle, right? So I'm trying to find, right, this angle here, and then also like that angle, there to there. Now, this angle I will find out by using the calculator. So in the previous case, we got 0.730, right? So that angle there is 0.730. Okay, then how can I find this bigger angle? Well, if we just think about symmetry just for a moment, right? That angle there has to be the same as that angle there, right? So that's also 0.730. So how could I find this angle? Well, I'd have to do pi radians, which is this thing here, minus the 0.730, which is what we did earlier, right? We did pi minus 0.730. Okay, so once I got this angle and that angle, how can I get all the other subsequent? Well, if I go round the full circle and get back to there, I've got another solution, right? So if I go round a full circle, I get back onto the same point, and going round the circle is the same thing as going round 2 pi. Right, so I can just take my 0.730 and add 2 pi, and add another 2 pi, and add another 2 pi. And the same thing with this. I can take that angle and add 2 pi, and I can add 2 pi, and I can add 2 pi. All right, so guys, what I'm trying to say is there are several different ways to think about this. Right, you can think about the trigonometric questions in terms of the unit circle, which personally I think is better. Or you can think of it in terms of the graph of sine and cosine. What you don't want to do, right, and I've noticed this with a lot of, a lot of my students, is you basically learn this like quadrant method where you guess what's going on and everything is essentially like magic, right? And we want to avoid maths, which appears to be pulling numbers from, pulling numbers out of a hat, basically, right? I know it's difficult what I've just done. I do understand that. But from your point of view, the best thing for you actually is to really understand what's going on. And the more you can understand what's going on, the more you're going to be confident with it, and the more you're going to feel actually that this is easy and within your grasp. Okay, so part of the biggest problem that you will face is you are going to try to learn tricks that seem to be faster, that are like shortcuts, but you can't actually explain what's going on. You've got no understanding of it. You want to avoid that as much as possible, right? If you go through the effort of learning what sine and cosine are, what the graph looks like, how to interpret it, then these questions, which are difficult, will become a lot easier. And for those of you who are looking to get your A star, that is exactly what you should be doing, right? That is the pathway to get your A star. Okay. All right. Well, I hope that was all helpful, guys. And if you find this video to be helpful, please like, subscribe, and please share with your friends. I'm always happy to be seeing more IGCSE students getting better at their ad math. Take care, and I'll see you next time.